In this lecture, we're going to revisit our C++ compilation model. Along the way, we're going to see that we can split our compilation process in two steps, and that is compilation and linking. And we're going to see that that's going to be very important for the topics we're going to talk about in this chapter. We already know that to compile our program, we're going to pass that through the compiler. So what we usually do, we issue a compilation command. Our program is passed through the compiler. The compiler is going to do its magic, and it is going to generate a binary that we can run to do things. But we want to zoom in on this compilation process and see what is happening behind the curtains. So when we compile our program, the first thing that is going to happen is pre-processing. And our source code is going to be passed through the preprocessor, and things like include statements and other things are going to be processed to be put in our translation units or CPP files in our C++ program. After pre-processing, we have a version of code which is really not what we typed, and we're going to pass that through the compiler again to generate object files. So after compilation, we're going to get object files, and these are going to be binary representations of our source code. After that, we're going to do what we call linking. And in this process, we're going to stitch together all the object files we have in our program, and the end result is going to be one binary executable that we can run on our system. So what we want to do in this lecture is try this out. We're going to compile our program in steps and see our object files and really get a feel of what these things really are. Okay, so now our compilation model has been updated. We have three steps. We have pre-processing, we have compilation, we have linking. But in this lecture, what we're going to be looking at is really compilation and linking, because pre-processing is really not that important for what we're going to talk about in this chapter. To compile our program, we will be doing our thing on the terminal. So we will be using a terminal like this, but you can really use any terminal as long as it works. There is no problem. And you should know that IDEs or editors like Visual Studio Code actually call compilers using the same techniques we're going to use here. They just provide a more convenient way to do this. So this should be a good lecture to also get a feel of what is happening behind the scenes as your editor or IDE is doing its thing. We're going to see how to do this using GCC because it is our main compiler in the course, but the same concepts apply to any other C++ compiler you may be using in your career as a C++ developer. You may be using the compiler from Microsoft MSVC, you may be using Clang. Any C++ compiler can really do this. It is a matter of searching and finding out how to do this thing. We will be using a simple program which is going to be split into three files. We're going to have a utilities header file. We're going to have a utilities CPP file which is going to contain some functions that we want to call. And we will have a main CPP file which is going to contain our main function here. So if we want to compile our program, we can do it in one go as you see here. And the command to do this is what you see here. We're going to call GCC, which is our compiler. We're going to pass a flag, which is going to mean that we want to compile and link. We're going to specify the output file, which is going to be our program, rooster.exe, and we're going to specify the source files. If we hit enter with this command, this is going to compile and link the program, and the output of this is going to be an executable that we can run directly. But we can also do this in two steps. Remember, we want to break this into compilation and linking so that we can see the object files that the compiler generates, and it is really crucial to understand this. So what we want to do is to break this in two steps. We're going to compile only, and the output of compilation is going to be a pair of object files. The command to do that is what you see here. We're going to call the compiler, we're going to pass a C flag, and then we're going to specify our input files. The output of this is going to be a pair of object files. Now that we have the object files, we can really do anything we want with them. For example, we can open them and see what is inside. We're going to do that in a minute. But the ultimate goal is really to stitch these object files together and get a final binary file. And the command to do that is what you see here. We're going to link up the object files or stitch them together to get the output file. And what we're going to do is say G++. We're going to specify O, and then we're going to specify input to the compiler. The input is going to be a pair of object files, and our object files will be the files that we got from the last step when we compiled our program only. And if you do this, you're going to be able to split your compilation in two steps. The first one is going to be compilation, which is going to generate object files. The second one is going to be the linking stage, which is going to take object files as input, and it is going to generate a final binary file that you can run in your system. As a word of caution, to be able to do what we are about to do, your compiler should be in your path, so you should be able to call it from anywhere on your terminal. And if it is in your path, you're going to have no problem with what we are about to do in this course here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is compiling and linking and compilation model here. We're going to grab our template files and we're going to copy them. We're going to put them in place. And we are going to open this little guy in Visual Studio Code. We are going to set up our project. So we have the main file here. Let's clean up whatever we don't need. And we're going to add a pair of utilities or functions that are going to be living in a separate file. So we're going to add a utilities header file. Let's do that. And we are going to add a CPP file for this. The header file is going to contain a pair of functions. So we're going to be adding up and multiplying stuff. And we're going to put implementations of these guys in the CPP file. Okay, so let's do that. We have the implementation for the add function and an implementation for the multiply function here. We're going to head over to the main function and include our utilities file. The header, that's what we want. And we are going to head over in the main function and try to use these functions here. So we're going to set up a result variable, which is going to be of double type. And it's going to add up maybe 10 and 20, why not? And after we do this, we're going to print the result out. We're going to say stdc out. We're going to say result. And we're going to print the result out here. Now the program is working. If we build it with Visual Studio Code or whatever, it is going to work. But what we really want is to see how to do these things on the terminal and eventually be able to break our compilation in two steps. The first step is going to be compilation, and the second step is going to be linking, and we want to see the object files that are generated after we compile and generate those object files here. So let's do this. We're going to bring up a terminal. Okay, so this terminal is working in this current directory. If we do ls, we're going to find our files. On Windows, you can also do dir to see what is inside your folder. We're going to see that we have the main CPP file, we have our utilities file, the header and the CPP file, and we can compile them. To be able to compile with GCC, you need to be able to do G++ here and do version. If we do this, we're going to see our G++ compiler. And if you see a message like this, you can call the compiler and do what we are about to do here. If you can't call your compiler, please make sure you have this in your environment variables. So if we do env on our start menu here and hit edit system environment variables, we're going to choose environment variables here. If you go to your path, you should be able to find the path to the bin directory where G++ is installed. If I go in my C drive, let's do that. I am going to bring up a window and we're going to go to my C drive. I am going to go in main GW, if I can find it. Can I find it? We have it here, main GW 64. I am going to go in. I am going to go in the same directory that I have here in my environment variable. And if I go in this folder, you're going to see that I have my G++ compiler right here. So you should have the same setup here to be able to call this little guy from a terminal. So make sure you have this in and you will be able to do what we are about to do. We have seen that it is possible to compile and link our program in one go using the command we see here. So we're going to head over to the terminal and do this. So what we're going to do is call G++. We're going to say G++. We're going to specify the O flag to mean that we want to compile and link. We're going to specify the output file, which is going to be rooster.exe. Then we're going to specify our input files. We're going to have the main CPP file, we have that in, and we have our utilities file. If we hit enter, this is going to compile our program. If we do ls, we're going to find a rooster.exe file. And if we run it, we're going to see that this is going to run. It is going to say result is 30. And in our main CPP file, this is what we are doing. We are adding up 10 and 20, and the result is going to be 30. Let's change the input here and make sure that we are really running this program here. We're going to say 20.8 here. And we're going to compile and link again. So let's bring this command up again, and we're going to compile and link. If we do ls, you're going to see our rooster.exe file. If we run it, we're going to get a different result. So our program is working here. We can compile and link it on the terminal in one go. Now, let's do ls, and we're going to remove rooster.exe here. And we want now to compile and link in two steps. The first step is going to be compilation. The second step is going to be linking. The command to compile only is what you see here. So we're going to say g++, specify a C flag, and then we're going to say our input as our main CPP file and utilities CPP file. Let's head back over to Visual Studio Code and do that. We're going to say g++, specify our C flag, and then we're going to say main CPP file and utilities CPP file. If we hit enter, this is going to run. If we do ls, now we see that we have a main.o file and a utilities.o file. If we open this up in our file system, let's do that. We're going to find in Explorer, and then we're going to find our main.o file. We can try and open it with an editor, and you're going to see that it's some gibberish because this is a binary file. It is meant to be processed by computers. It is not meant to be read in editors like this. So this is really cool. We are able to generate an object file. Now, what we want is to use these object files and generate a binary file. And the command to do that is what you see here. We're going to link up our object files. We're going to call the compiler. We're going to specify our flag. We're going to specify the output file, and then we're going to specify our input files to be main.o and utilities.o. Let's head over to Visual Studio Code and do this. Okay, so we are back in Visual Studio Code. We're going to say g++, and we're going to specify our O flag. We're going to specify the output to be rooster.exe, and our input is going to be main.o and utilities.o, which are our object files. If we run enter, we're going to see that this is going to run. If we do ls, we're going to see that we have a rooster.exe file, and we were able to generate this from our object files. If we run rooster, we're going to see that we get the exact same result we got before. So this is really how you can compile and link in two steps using the G++ compiler that comes with GCC. Hopefully this is going to shed light on how some things are done, and you have to note that function calls are resolved at link time. For example, if we try to call this function here and we don't have a function definition here, compilation is going to work because the compiler is really interested in declarations, and our declarations will be brought in by the include that we are doing here. So the compilation is going to work, but linking is going to fail. Let's try and do that. We're going to comment out our implementations. Let's do that so that they are disabled. And we're going to try and compile this program again. We're going to clear. And notice that we are calling the add function in main. This is what is going to cause problems here. If we try to compile the program, let's go up and see if we can find our compilation command. Let's do ls and remove all the clutter that was generated. We're going to remove a main.o. We're going to remove the utilities.o file. And we're going to remove rooster.exe. We're going to clear and run ls, and we're going to see that we have our source code here. This is really cool. So we're going to go up and find our compilation command. We want to compile this program and generate our object files. If we do this, you're going to see that compilation is going to work, and we're going to generate our object files here. But if we try to link them, we're going to get a problem. Let's try and do that. We're going to bring back the command to link. I think we have it in our history here. We have that here. If we run this, you're going to see that we have a problem. Undefined reference to add. This is something you can understand now because function calls are resolved at link stage. And the compiler doesn't really care that we don't have definitions in. The compiler is just happy looking at the declarations here. And this is something I wanted you to see in this lecture. This is really all I had to share in this lecture, showing you that you can compile your program on the terminal and break things in 2 steps. The first step is compilation. The second one is linking. And now you know that function calls are resolved at the link stage. And if you don't have your definitions in, you're going to have undefined references as we see here. We're going to stop here in this lecture. In the next one, we're going to shed some light on declarations and definitions and learn a little more about these important concepts in C++. Go ahead and finish up here and meet me there.